Airplanes come large and small, with many different configurations. And yet all of those we have seen have one fundamental purpose: to get people and goods from one place to another in a minimum of time. Just as there are many types of aircraft to meet different needs, there are many sizes and many different types of thread-cutting die heads and taps to meet varying requirements. All have one fundamental purpose: to thread parts accurately in a minimum of time, at a cost in line with the mass production needs of today. Each must be selected to be the most efficient for the threading job to be done. First, let's consider self-opening die heads. A self-opening die head permits the thread to be cut and the head rapidly removed from the work without unscrewing it. This feature provides high-speed operation, yet prevents damage to the new threads. Die heads contain many separate parts. The major components of a geometric type head are the skeleton, the cam, the back part, and the shank. The skeleton holds the chasers in accurately ground slots. The cam has 4 push buttons which snap into the chaser lug slots for chaser retention. In addition, the cam has 4 protruding lugs which, when partially rotated, cause the chasers to close or open. The back part holds the die head together. The shank adapts the die head to the machine in which it is to be used. Now let's see exactly how a self-opening die head operates. In this demonstration, we can see the rotating workpiece as it is engaged by the chasers of the advancing die head. When a predetermined length of thread has been cut on the workpiece, longitudinal travel of the turret is stopped. The work continues to rotate, however, and since it is rotating and the newly cut threads are engaged with the chaser teeth, the work exerts a pull on the die head, which soon grows strong enough to actuate the opening mechanism, and the chasers snap open into the skeleton, away from the work, as shown here in slow motion. When the chasers have disengaged the work, the operator returns the die head to its starting place. One simple movement of the closing handle brings the chasers back to the cutting position. The die head has completed its cycle and is ready to thread another piece. Basically, there are 2 types of opening die heads. The stationary type is held rigidly and the workpiece revolves. This type is used on turret lathes and single spindle automatics. The rotary type die head, on the other hand, revolves and the workpiece is held stationary. This type is used on many types of live spindle machines. Whether of the stationary or rotary type, opening die heads are further classified according to the type of chasers employed. Here is the so-called geometric radial type die head with distinctive chasers which fit directly into slots in the die head. To mount chasers in this type of die head, the tool is tripped and the stop plunger pulled out so that the cam lugs clear the chaser slots. Now the chaser marked number 1 is slipped into the slot marked number 1. The chaser is pushed toward the center of the die head until the push button snaps into the chaser cam lug slot. Chasers number 2, 3, and 4 are slipped into their respective slots. The insertion of this type of chasers into geometric type die heads is simplicity itself. When all 4 chasers have been inserted, the die head is closed with the closing handle. The chasers are now in cutting position. Another type of die head employs tangent type chasers and is characterized by the use of chaser holders. Chaser number 1 is inserted into holder number 1 as shown. Then the setting gauge is attached to the chaser holder, where it is held in a positive grip by the gauge holder screw. The chaser is moved forward until the cutting edge contacts the side of the gauge and the chaser abutment screw is nipped up. The chaser binding screws are then tightened to firmly hold the chaser in position. Chasers number 2, 3, and 4 are mounted in their respective holders in the same manner. Each chaser holder with its chaser is inserted into its corresponding dovetail slot. The die head is closed to cutting position. Using a threaded part or a root plug as a gauge, the die head is adjusted to cutting size by turning the adjusting screws. The machine is indexed, proper threading speed is selected, and the coolant is started. With the die head aligned using the aligning shank, the head travels forward, cutting the thread until the desired length of thread is completed. The head opens, the turret is retracted, the head is closed again, and the machine is ready to cut another thread. Buffer action built into the tangiometric die head will yield slightly as it starts on the work. If this action is not desired, it can be locked out with the buffer adjusting screw. Chaser holders with their chasers can be easily removed from the tangiometric die head without disturbing the work setup. Chasers may be replaced in the holders, and the holders positioned again in the die head, ready to go to work. Preset chaser holders and chasers help keep machine downtime to a minimum. By using the proper chaser holders and chasers, the same die head can be used to cut a wide range of diameters and pitches. There are various methods of opening and closing the chasers on a self-opening die head. Stationary type die heads are closed manually with the closing handle, or they can be operated mechanically by one of several means. Here we see the opening accomplished by means of an outside trip. The outside trip gauge contacts a stop on the machine. The rearward movement of the trip gauge causes the die head to open. Here we see the action of a pull-off trip. When set for a predetermined length of thread, the longitudinal travel stops, and the pull exerted on the head causes the opening mechanism to trip. High production setups demand the utmost in rugged construction and precise operation. This 9/16 inch head uses an outside trip with this automatic setup. Here, a 5/16 inch head is operating with a pull-off trip. The rotary type head has no manual controls, and all opening and closing is done mechanically. This head is opened and closed by a yoke and trip rod mechanism, which provides both positive opening and positive closing, and can be installed on almost any live spindle machine. Compact design and yoke tripping make this type head ideally suited to jobs where there is little machine clearance. Here's another high production setup that demands the most reliable threading tools available using a rotary head. An aligning shank, which can be used to compensate for misalignment, is an available feature on stationary die heads. The two square head screws at the rear are loosened, allowing the head to float freely. Then the head is fed to a true running work blank until the chasers are fully engaged. The machine is stopped with the chasers still engaged with the blank. The binding screws are tightened and the job is done. This feature results in increased accuracy and reduced downtime. The tools demonstrated so far have been of the self-opening variety. The solid adjustable die head is another type and may be used advantageously for certain jobs. For example, solid adjustable die heads are made in a wide range of sizes, from large tools capable of cutting threads 6 or more inches in diameter to this very small model. Outstanding features of this fine tool are compact design, simple operation, positive chaser adjustment, close to shoulder cutting, and important too, low initial cost. This tiny, solid adjustable die head, 1 inch in diameter and weighing less than 5 ounces, is capable of cutting Class 3 threads day after day. Projection chasers are furnished to facilitate cutting to a shoulder. This tool has the advantage of easy chaser insertion and adjustment, and has a threading range up to number 10, and in pitches as fine as 120 threads per inch. Parts requiring these fine threads, to name just a few, include cameras, scientific instruments, eyeglasses, and timepieces. Tangiometric solid adjustable die heads can also be used with cutters for turning as well as with chasers for threading. Each set of chaser holders can be adjusted for a wide range of diameters, and the same cutters can be used for any diameter within the range of the chaser holders. Just as with the tangent chasers we have seen, the cutters and chaser holders can be removed without removing the die head from the machine. Most geometric radial type die heads can also be equipped with cutters instead of chasers for die head turning, pointing, and forming. So far, we have seen many types of die heads which produce accurate external threads. Now, let's look at precision collapsing taps, which are used for many internal threading jobs. Like the die head, the collapsing tap is a thread cutting tool. It is used to cut internal threads of precise form, pitch, and lead. Because the tap collapses at the end of its threading operation, it also can be rapidly withdrawn from the workpiece without unscrewing it, permitting fast operation and avoiding damage to the new threads. Main components of the collapsing tap are the skeleton ring, the trip plate and closing sleeve, the adjusting ring, and the plunger. The skeleton of the tool acts as a self-contained shank. The tap skeleton holds the chasers in accurately ground slots. A tongued plunger engages the rib on each chaser, and its action, backward or forward, causes the chasers to collapse or reset. Let's see exactly how this collapsing tap operates. A cutaway tap and a piece of cutaway stock enable us to look inside the tap at the end of its longitudinal travel. The trip plate on the tap meets the end of the workpiece. In slow motion, we can see that the rearward movement of the trip plate causes the spring-loaded plunger to move backward, collapsing the chasers, disengaging them from the work. The tap can be rapidly withdrawn. A movement of the closing handle brings the chasers back to the cutting position. The tap has now completed its cycle and is ready to thread another piece. To satisfy every known machine requirement, the geometric collapsing tap is truly a universal tool. 4 easily interchangeable trips enable the taps to be used on a variety of machines. This is a stationary type tap with a trip plate. It is designed for use on hand screw machines and turret lathes. It is collapsed by the trip plate and reset by the closing handle. For use on drill presses or live spindle machines, this tap is equipped with a plate trip. The tool is collapsed by the trip plate and reset by a stop arrangement which contacts the back part of the closing sleeve. When high production tapping is to be done on automatic screw machines, chucking machines, or drill presses, the collapsing tap is equipped with a sleeve trip. The tool is collapsed and reset by a yoke riding in the sleeve. Here is the same tap with trip plate removed. It is ideal for short runs, sizing, and special jobs where the unusual construction of the part to be tapped requires hand operation. the tap is both collapsed and reset by the closing handle. This tap will thread 3 distinct kinds of jobs. Most common of tapping operations is through-hole tapping. The tap threads the part through its entire length. A more difficult and less common tapping operation is bottoming tapping, where threads are cut to the bottom of a blind hole, or in this case, to a shoulder. To do this tough job, the tap is equipped with a bottoming cap and overhanging chasers. Special length taps are available for deep hole tapping. The entire tool, particularly the shank, must be exceptionally rigid or the tool will wander, causing oversized, out-of-round threads. In addition to collapsing taps, high-quality, solid, adjustable taps are also available. Within its capacity, this tap will do any job that a conventional solid tap will do. Where time for backing out is unimportant, or where space is limited, as on a vertical drill press, a solid adjustable tap is recommended. Chaser adjustment on this tool is extremely simple. Just loosen one adjusting screw and tighten the opposing adjusting screw. Interchangeable chasers of sizes within its range enable this rugged tool to take the place of several solid taps. This tap will do bottoming tapping if overhanging chasers and a bottoming cap are installed. For economy's sake, chasers for solid adjustable taps are interchangeable with chasers for collapsing taps. Ground thread chasers are standard for both tools. Now let's look at the chasers themselves in more detail. Radial die head chasers are divided into 2 general types: regular and projection. The regular chaser used for straightaway threading is the more common. The projection chaser derives its name from the fact that part of its cutting face projects beyond the front of the chaser. This important feature permits cutting close to a shoulder and provides for increased grinding life. Threads on regular and projection chasers vary in profile depending on the method used to produce them. Standard chasers, which have this angular profile, are produced by either grinding or milling. Tap chasers, which have this concave profile, are preferred by many users. Geometric produces several different kinds of chasers for die heads. They are the D, the K, and the tangent type. The same kinds of chasers are also available with carbide tips. S-type chasers for taps come in both high-speed steel and carbide. Cutters for die head turning are available in carbide tipped as well as in high-speed steel. Special cutters can be furnished for end pointing and forming. For maximum quality in chasers, every surface should be ground to close tolerance, such as these supermetric chasers. Precision grinding of every surface pays off in terms of smoother action in the head, longer life, and more accurate threads. In the inspection department, chasers must pass under the watchful eyes of experts trained in the science of inspection. These chasers have been inspected a dozen or more times in preparation for the final test. To make certain that chasers will perform to established high standards, they are put to work doing the job expected of them on a battery of turret lathes. This is the payoff. They must cut a clean, accurate thread that is more than just satisfactory. Only after meeting the most exhausting requirements is a quality product prepared for shipment to stocking distributors throughout the world. Even the finest tools require sharpening after periods of hard usage. This is the Style A chamfer grinding fixture. With this single tool, either ground or milled chasers can be re-chamfered. The Style E universal chaser grinding fixture is designed for rechamfering all geometric type conventional radial chasers. It can also be used for grinding the cutting face. Geometric tools are at work throughout the country wherever threading time is important. Here, a tangent type rotary die head in a special purpose machine is threading a front axle spindle in a plant of a large motor car manufacturer. Carbide tip chasers are used for maximum production. In this high production vertical chucker application, carbide tip chasers are being used to tap steering gear units in a plant of a major parts supplier. Geometric Tool Company, for over 70 years, has been producing a full range of quality threading tools to perform the job to be done in the shortest possible time. Available through conveniently located industrial distributors, these tools represent outstanding examples of the finest threading tools used by modern industry.